we're going to do is we're going to look at the carbon cycle. Now, carbon cycle looks at the movement of carbon from the inorganic part of an ecosystem into the organic part. And the reason we're so interested in the movement of carbon is it forms the backbone of all molecules in living things. So it's used to make every molecule in your body. Now, most of the carbon dioxide, or carbon, exists as carbon dioxide in the atmosphere. Now, there is lots of other forms of carbon out there in the atmosphere, or in the environment, both organic and inorganic. But the inorganic carbon dioxide in the atmosphere is the primary method in which it gets into the biotic component. And it does this through photosynthesis by plants. And so plants take in the inorganic carbon dioxide, and so the abiotic carbon dioxide, and they undergo photosynthesis, and they turn it into a biotic component of their bodies. And then they can use this for themselves. They can use it to store energy. Animals can consume it. But ultimately, the main way that the carbon that has been taken out of the atmosphere and placed into organisms gets back into the atmosphere through cellular respiration. Now, we do have long-term storage of carbon from the atmosphere into both the soil and in the ground. But when we're looking at the cycle of carbon through the biotic and abiotic component of an ecosystem, it occurs through photosynthesis and cellular respiration. Now, most of the carbon dioxide is in the atmosphere, and as we stated, photosynthesis takes it out. And it's taken out, and this is done by plants. Now, terrestrial plants do it on land. In water, we have another organism that helps with this as well. Then animals will consume the plants so that they can get carbon into their bodies so that they can make all the molecules that they need. And then when these organisms die, then decomposers will break it down, and this helps to form soil. At the same time, while all of these organisms are undergoing cellular respiration, and so they will return some of the carbon back to the atmosphere. And so when we look at the amount of carbon that plants take in during photosynthesis and compare that to the amount in the soil, it's very little of what plants take in end up in the soil. A good chunk of it, through cellular respiration, ends up back in the atmosphere. Now, if we have long-term storage, what can happen is if when these organisms die, if the situations are right, it allows for the formation of fossil fuels. And this allows for the long-term storage of carbon in the ground. Now, we humans have taken the fossil fuels that are stored in the ground and through combustion have used it so that we can power a large amount of our industry. A second method for removing a large amount of carbon from the atmosphere is it will dissolve in the ocean. So carbon dioxide in the atmosphere will become carbon dioxide dissolved in the ocean. Much like if you took salt and stirred it into water, it would dissolve. Carbon dioxide also does this. The amount of carbon dioxide that dissolves in the ocean is very temperature dependent. The colder the water, the more carbon dioxide that can dissolve. Now, this carbon dioxide is taken up and used for photosynthesis by plants living in the water. We can have single-celled plants, algae, and we can also have something called cyanobacteria. All of these are aquatic organisms which will undergo photosynthesis and help to produce oxygen in their atmosphere and also take carbon dioxide out of the atmosphere. Aquatic animals will consume these aquatic plants. Of course, they'll die, all of them, and we can have cellular respiration that returns it to the ocean, and we can have a cycle in the ocean, but also we could have it undissolve and go back into the atmosphere.